So when we're looking at rational functions, we should be asking ourselves what kind of behavior should we expect to find on either side of places where we know that the function will be undefined. And we know that there's a couple of places right here. For example, in this first one, we know that at x equals 4, this function has an undefined value. So one thing we're really interested in when it comes to these kinds of limits is just asking the question, what behavior happens to the left and right of each of those points? So f of x right here, this is sort of a straightforward one. If we talk about something like a limit as x approaches 4, and let's take it from the left-hand side first, of 3 over x minus 4, how should we handle that? My technique, the way that I like to deal with this, is to think about what does this mean? Well, when we say the limit as x approaches 4 from the left, we're taking values that are slightly less than 4 and subtracting 4 from them. So we might think about it this way. As we take values that are slightly less than 4, I'm going to write 4 with a little negative symbol to represent that, and we subtract 4, well, we know that 4 minus 4 is actually 0, but what if we have a number that's approaching 4 and we subtract 4? Well, it depends on which side we approach it. Since we're approaching from values that are less than 4, take a number slightly less than 4, 3.9, subtract 4, you're going to get a negative number. So we're going to say that's approaching 0 from the negative side. And what that means to me is that I've got a positive number, and in dividing by a slightly negative number, well, it doesn't matter how slightly negative it is, it's negative. A positive divided by a negative is negative, and we always get a limit that tends towards infinity. So we're going to say that this is tending towards negative infinity. Now let's look at it from the right hand side. Let's take that limit as x approaches 4, from the right hand side. So values that are slightly larger than 4 this time. So we're taking the limit as x approaches 4 from the right of 3 over x minus 4. When we substitute into this expression right here, that means take some values that are slightly larger than 4, subtract 4 from that value. What happens? Well, we're going to treat that as 3 over something approaching 0, only this time slightly to the right of 0. Well, now we've got a positive number divided by a positive number. We know that whenever we have a number that's approaching values that get close to 0 in the denominator, we tend towards infinity or negative infinity. And so we're going to identify and say this is positive infinity. So as x approaches 4 from the left, we go to negative infinity. As x approaches 4 from the right, we go to positive infinity. Will it be the same for g of x? Well, again, we need to explore around x equals 2 to see what happens right here. And it does make a difference the way that we state this expression right here. Because let's take our limit, this time as x approaches 2 from the left. Should we go to negative infinity? Is that always the case? Just from the left, we go to negative infinity? Well, no. Let's look at this. We're subtracting x from 2 this time. So it makes a difference that 2, where x is approaching a number that's approaching 2, uh, that from something slightly less than 2. So we're saying something kind of like this, 1 over 2 minus something slightly less than 2. Well, that's approaching 0, all right, but it's approaching 0 from something this time slightly greater than 0, because as we take a larger number and we subtract a smaller number, we get a positive value. We know that that tends towards either positive or negative infinity. Since we've got a positive in the numerator, positive in the denominator, we're going to say that goes to positive infinity. Again, letting x approach 2, this time from the right, we're going to pick values that are slightly larger than 2, and we're going to subtract them from 2. So we've got 1 over 2 minus x. When we make the substitution in here, we're taking 2 minus something approaching 2 from this larger than 2 side, right? So that means 1 over, let's see, 2 minus something slightly larger than 2 is something less than 0. And since that's a negative number in the denominator, we're going to say that from the right-hand side, we're going towards negative infinity. So we can't just go by left, right as negative and positive. We have to look at what actually happens in each of the factors in the denominator. All right, one more to look at right here, and that's our function h of x. This time, we've got a slightly different thing happening. We've got x minus 1 in the denominator, so we want to look at what happens near x equals 1, but this time, we've got a square. How will that affect things? Well, in this case, we're going to be taking our limit as x approaches 1 from the left of 2 over the quantity x minus 1 squared. When we take a number that's slightly slightly smaller than 1, we subtract 1. Well, of course, we know we get a negative number. So we're saying 2 over something approaching 0 squared. Well, that square changes things, doesn't it? Right? That means that we're actually approaching 0, but it will be a positive number. So we're going towards positive infinity as we approach from the left. So having an exponent can change that. And let's take a look from the right-hand side, just to wrap this one up as we take the limit as x approaches 1 from the right of 2 over the quantity x minus 1 squared. We know that we're approaching 2 over something slightly larger than 1 minus 1. We're squaring that value, so we've got a number that's approaching 0 in the denominator. And even though we're squaring that should be a plus in here, right? Even though we're squaring that, it's still going to be positive, so we're going to say it goes towards positive infinity on the right. We'll have a little bit more discussion about this interesting effect here later, but there we go.